without significant size manipulation or size reduction processes. And if we have non-comminuted meat, there are a number of techniques we can use to preserve them. And for some, we'll also be looking at ways where we actually add value. But widespread or basic way to preserve non-comminuted meat is really through cold storage. And we've spoken about the importance of temperature, put into consideration because temperature does affect the biochemical and microbial processes. So just by chilling meat, we are able to extend its shelf life, and by freezing it, we extend the shelf life even more. And this is because biochemical processes, chemical processes, and microbial processes depend on the temperature. So we reduce those spoilage processes by reducing the temperature. It's important also to know that there is some form of synergism or synergistic effect between chilling or cooling and other preservation techniques. So if you have meat, when you package it and you chill it, you improve the shelf life even more. So things like modified atmosphere packaging or adjustment of the pH, say through fermentation, you ferment and you chill it, you're extending the shelf life more. It's important also to think about the humidity, because once the humidity around cold stored meat is very low, then the meat loses water and therefore loses weight. If it's very high, then you have surface causes the meat not to preserve very well. So it's recommended that during cold storage, the humidity should be maintained within the range 87 to 91%, and that enables meat not to lose moisture due to surface evaporation, but also no accumulation of moisture around the surface of the meat. We say that chilling is basically refrigerating without formation of ice, but sometimes we want to have sufficient low temperature so that we have long storage. It's recommended that when you keeping your meat under frozen storage, the temperature should at least be -18, should be -18 or lower. And this is sufficient to hold microbial activity, but some chemical changes still happen. If you look at you have something like that. First of all, chilling from A to B. From B to C is super chilling, where you go beyond frozen temperature. Then some warming happens, then continuous chilling until you have basically no active water, no water available for biological processes. When you're thinking about the percentage of water that is present versus the temperature, as you move from zero to the negatives, the amount of water that is frozen increases, but we of course can never freeze 100% because the bound water doesn't get frozen. So the temperature in the first few degrees below 0 degrees Celsius, that's when most of the ice is formed, and thereafter there isn't additional formation of ice. Different methods can be used for freezing. If we want to freeze meat, we can use different techniques, and these vary in the speed of freezing and, of course, in the ultimate, the ice sizes, which affect the stability of the ice particles during frozen storage. Still air, quite slow in freezing, very slow in freezing because the air is not moving, and therefore the temperature changes within the meat are not as fast as desired. But still, so your home freezer is an example of freezing using still air. We can also use plate freezers. This is where you have the chilling plates at multiple levels, and when you put thin amounts of meat on there, the freezing or the loss of moisture through conduction faster than still air because of the contact surface area being high. We can have cold air blast, low temperature air being blasted around. This is quite fast chilling. And also have and sprays. Here you have the meat or whatever products immersed in a liquid such as brines, glycerol. The food should be raised and it's chilled in the process. Then we have cryogenic freezing. This is where we use things like liquid nitrogen, liquid carbon dioxide to freeze food. We've spoken about glazing. It's important, especially for things like fish. If you are not going to package it, that you have a layer of ice formed around the fish, and this is through glazing. And glazing, we've said, is a thin situation where we facilitate the formation of a thin sort of wraps around the fish, making it not lose moisture. So this can be done, say, by dipping the ice into brine, chilled brine, super cooled liquid before. And when you remove it from the dip, there is a nice layer that is formed. And every time we are thinking about freezing, we should target to have fast freezing, and we should also target to have hot temperatures during frozen storage. When we freeze fast, the ice formed small crystals, and that is good for quality of the food. If you are not speaking, I expect you to mute. Otherwise, you disrupt the class. So what are the changes that occur in frozen storage? We have said that frozen foods are stable, but they are not 100%. They are not. It is not like when you frozen food, that no change is going to happen at all. Some changes still happen, and these changes include some physical, some chemical. As far as the physical change, you can have sublimation, which is the loss of water from the frozen food, and this can happen, and it is facilitated. It's more at sublimation to happen. It is also facilitated by temperature fluctuations. No, the lower the frozen temperature, the lower the sublimation. So if you store your food, we said minus 18 is recommended. If you store it at minus 40, then you have very minimal sublimation. If you store it closer to minus 18, then you have more. In some cases, there are like some of these domestic freezers may even get higher than minus 18, in which case sublimation would even be more. Then I've mentioned temperature fluctuations, of course, packaging. When we have packaging, if you can't keep your mic off, you'll force me to eject you from the meet, the class. So people, let's keep our mics muted. The temperature fluctuation is a problem. So apart from freezing the food fast, the temperature should be stable. If the temperature keeps going up and down, then you have more sublimation. Then apart from sublimation, recrystallization, this is where the ice within the food starts changing in size. You have growth of the size particles when you freeze very fast. That is associated with small ice crystals, but the crystals can grow during storage. And this growth of ice crystals during storage is also associated with it. Fluctuations in temperature, but also happens more at higher storage temperature. Then freezer burn, where you have the surface damage. And for example, if you look at frozen foods, you may see patches due to some localized sublimation, like the damage is more at some surfaces than at others. So those are the physical. We also have chemical changes, including changes in proteins, changes in myoglobin, and changes in lipids. For the proteins, during storage, we may have agglomeration or complexing of proteins. And in fish, it is very common, and it's been associated with the breakdown of TMAO to give you the DMA, dimethylamine, which is associated with the protein cross-linking, and this leads to the texture of the meat changing. The other chemical process is lipolysis and oxidative acidity. The chemical changes within lipids during frozen storage continue, and to avoid these things, like use of antioxidants or proper packaging helps. Lastly, myoglobin can be oxidized methylmyoglobin, which is associated with changes in appearance. So those are some of the chemical changes which occur under frozen storage. And for all these changes, the lower the temperature, the less they change, but also the fluctuation of temperature is generally associated with more of the changes that occur during frozen storage. From the biological angle, we have some microbes which get damaged or even killed during frozen storage, and some parasites as well, like the tapeworms and some of the other parasites have been known to either get damaged or even by extended frozen storage. So in other words, frozen storage is not completely something without activity. There are some changes that are happening to the food, and those changes include the physical, which you've seen, the chemical, whether it's with proteins, lipids, or myoglobin, as well as some biological changes. When we've frozen meat, before you consume it, before you cook it, normally you need to thaw. And while we normally recommend that freezing should be fast, thawing should be slow if it is going to preserve the quality of the meat. A high temperature difference, rapid, like getting meat from your freezer and you put it in the microwave, that is associated with the fast thawing, and fast thawing leads to a lot of drip loss. Drip loss is that amount of moisture or water that leaves meat as you thaw. And you want to minimize that. If you have a lot of drip loss, it's associated with texture which is not juicy, and that is not a good eating experience for people who are going to consume the food. So thawing normally should be slow, and you need to regulate the temperature during thawing, because if let's say you get meat, you leave it out thawing at ambient temperature, but for a long time, then microbial proliferation may also start. So it also needs to be regulated. If you're going to remove food from the freezer and you want it thawed, you can put it in the refrigerator first. And that means that while it's thawing, the microbial proliferation is still under control. So these are some of the methods we can use for thawing. Just warm air, that's a bit slow. Immersion in water, that is faster, but it is associated with higher drip loss. Wave defrosting, and this is very clear. When you're using microwave, you need to use the defrost function, not the cooking. Otherwise, then you end up cooking food which is not thawed, and that will lead to some parts being cooked while the interior is still chilled or even frozen. Any questions up to that stage? So, Mariam, why should we freeze first? Why should we freeze meat first?
So it's all about controlling the rate at which microbial spoilage can happen to the meat.
Alan, why should we freeze meat first?
To avoid giving the meat texture.
Okay. Daniel, why should we thaw slowly?
To avoid microbial proliferation.
Prof, I think freezing slows down.
So why should we thaw slowly? Why not very rapid? Why is rapid thawing not recommended?
I think it may cause damage to the meat itself. If it is done rapidly.
The slow thawing maintains the meat quality, maintains the quality of the meat and those other parameters inside the meat particularly.
What is drip loss? What do we mean by drip loss? What do we mean by drip loss?
Prof, I think this is the liquid that comes out when we are thawing the beef.
So how is drip loss related to the speed of thawing?
When you do it like at high speed, maybe when you use a microwave, hot water, you're trying to force the thawing at a high speed, hence too much of the liquid will be lost, which will have the other, and that may also affect the texture of the meat or the beef.
Okay, and any of the biological changes that happen in frozen storage? And a biological change that happens during frozen storage?
Among the biological changes is death of the microorganisms and the parasites, which some of their cell membranes is repaired during that low frozen temperature.
Okay. Any danger of fluctuating temperature during frozen storage? Any negative consequence of fluctuating temperature during frozen storage? Margaret?
Yeah, it causes it may lead to formation of larger crystals in the meat, affecting the structure of the meat.
Okay, good. So make sure you don't leave these principles or concepts are not understood at this point. When we finish the lecture, go over them, have them solidly understood so that we can deal with the application more easily. Now, we've said that cold storage may be used alongside other preservation techniques. And when we do that, normally there is a synergistic result, the preservative result of the two combined is higher than the preservatives separately applied. And one of the techniques that is usually applied together with the cold storage is modified or controlled atmosphere packaging. And these two terms, controlled and modified atmosphere packaging, mean slightly different things. They are very related, but they mean slightly different things. Modified atmosphere just means we have changed the gas composition around the meat or around the food product. Meanwhile, for controlled atmosphere, we allow the environment of the meat to continually change, taking into account things like respiration. So if you're dealing, say, with the fruits, oftentimes they are still respiring, and we can control the atmosphere around them, taking into account the physiology. So with meat, we are mainly talking modified atmosphere, and what we do is we are going to remove the normal air surrounding the meat and substitute it with a combination of gases. And that combination is meant so that it can extend shelf life, maintain meat color, avoid shrinkage, but by packaging, we can then have branded products that can be marketed as so. These are the gases we normally, those are their roles. We use nitrogen. Nitrogen enables us to not have a vacuum, so it equalizes. You extract the air around the meat, but you put back nitrogen because so that you avoid vacuum. Because once you have a vacuum, then you're going to have some shrinkage and things like that. But apart from that, it's inert, which means that it's not very supportive of the spoilage processes. Carbon dioxide is another, and one of the benefits of carbon dioxide, very, very important, is that it extends the lag phase for microbial growth. Somebody explain to us what the lag phase is in microbial growth, and what the other phases are in microbial growth.
I think this is the period when so the substrate are going to, or the food are going to either destroy. Then we have the lag phase, we have the log phase, the stationary phase, and the death phase.
Good. So normally when you have microbes within the food and they've been introduced, they start by hardly growing. The population is not increasing. The rate at which the cells are dividing is equal to the rate at which they are dying, more or less. So the graph, if you have to draw a graph, that area is basically flat and it's called the lag phase. and as explained, it's a period during which the microbes are getting acclimatized to the environment. And the more you extend that lag phase, that means that the food will stay longer if we extended the lag phase of the microbes. So that's benefit. And carbon dioxide helps us to do that. It makes the starting of the rapid growth to come later. And the rapid growth is the log phase. By postponing it, that is good. If you have too much carbon dioxide, then the color of the meat becomes poor. There's some form of discoloration, and then the reading assignment I've given you about meat color, you'll understand that. The other gas, which is very important in meat packaging, in modified packaging of meat, is modified atmosphere packaging is oxygen. And this is because oxygen contributes to the color of meat. That reddish, pinkish color of meat is only maintained in the presence of oxygen. So while in a lot of foods, people remove oxygen or lower the level of oxygen very much, in meat, you can't do that, otherwise you will damage the color. The process for getting your meat packaged using modified atmosphere is very simple. Basically, it means you first get the cut, and it's good that you have a fresh cut. You put it in the container you want it. Normally, we have some guard material, which means that it's not just the polythene pouch, but some material which would be used eventually for holding the meat. Then you vacuumize. That means you extract the air around the meat. Then you backflash with the mixture that you've decided upon, and you seal. This is when you're dealing with meat which has bones, then there is a problem. There is a possibility of the bones piercing the pouches, the liner pouches, causing the atmosphere to be, the modified atmosphere to be lost. So that is not when you're dealing with meat which doesn't have boneless meat. So modified atmosphere packaging is one way we can extend shelf life of non-comminuted meat. The other way is irradiation, not very widely used, but it is being studied, and it is also been applied to a limited extent, commercially, especially in pork. And this inactivates endogenous enzymes. We've said that the spoilage in meat or the changes, the loss in quality in meat is partially due to the enzymes which are endogenous to the meat. So the irradiation inactivates those enzymes, but also destroys microbes. And we can use different levels of irradiation, with the highest being equivalent to canning or commercial heat sterilization, which is often referred to as appetization. And if it's appetization is derived from the guy who first spoke about canning, or actually the effect of heat on microbes. And because this is not heat, it's radiation, then this is called radapatization. And that's the highest level of application. It leads to commercial sterility. Then we have radiorization, which is intermediate treatment. And this reduces microbial numbers significantly, but sterility is not achieved. It basically destroys pathogenic forms, vegetative forms of pathogenic microbes. And if you're to compare it to heat, also is almost aligned with pasteurization, this is radiolarization. Then the most mild is radicidation. This is the reduction numbers of viable non-spore-forming pathogenic microbes and inactivation of the parasite Trichinella. So these are different levels of application of irradiation to preserve meat. And the effectiveness of these treatments is influenced by other factors such as temperature. And we've mentioned how the two can work together. It's influenced by pH, more effective under low. I'd say influenced by water activity, again more effective under lower water activity, availability of nitrite or nitrite as an additive, and sodium chloride also do influence these, as well as the medium. So that is about irradiation, which is a form of preservation. The other form of preservation, which is more chemical, is curing. Curing, this is where we use salt and other additives to preserve meat. And curing does achieve meat preservation by lowering water activity. But also some of these additives have bactericidal activity. They are able to kill microbes. Then cured products normally possess a pink color, which is associated with nitrite, presence of nitrite. And during curing, we can use different methods, including dry curing. Generally, these methods are divided into what we call dry curing and wet curing. And dry curing, we just use the pure ingredient in its solid form, apply it directly, and then some moisture will get to be exuded through osmosis, and then eventually that forms some very concentrated brine around the meat, which then is imbibed. Meanwhile, for wet curing, you can immerse. We'll see a little of these sites, but the sites that come, you may immerse, or you may actually use syringes to introduce brine or cure ingredients into the meat. So what are the cure ingredients? We have common salt, and those are the levels, adds flavor, taste. But one very important aspect is it increases gel strength of butters. And this is because we said myofibra proteins are soluble in salt solutions. So these are then extracted because we have salt, and then they bind any form of meat. If it's minced meat, it is the binds together because of the myofibra proteins that have been extracted. It's of course it's a concern that people are of health interest to have minimized the amount of sodium chloride that we use in meats as a cure ingredient, and to achieve lower levels of sodium chloride. Sometimes we use a combination of sodium chloride and potassium chloride. And this can help us achieve the improved gel strength that we need for butters or for making things like sausages, but at the same time not have very high salt, which is detrimental to health. These are the other ingredients. We can use sugar, also contributing to water activity lowering, but sugar can be involved in Maillard reactions, which affects meat color and meat flavor. It also makes the saltness more tolerable, and a level of about 2% sugar is normally considered acceptable. Nitrite, another very important pure ingredient, and it contributes to the reddish color associated with the cured products. It contributes flavor, but most important, it contributes to a control of microbes, especially the fetal microbe Clostridium botulinum, which has been linked to meat, especially canned meat. It retards development of rancidity, but it has also been associated with some carcinogenicity. In other words, the presence of nitrite in meat allows it to interface with other meat components, causing compounds called nitrosamines, and these nitrosamines are considered carcinogenic. This is roughly what happens. If you have amines such as dimethylamine with the nitrite, you get diethyl nitrosamine. And these nitrosamines, this is an example of a nitrosamines. These nitrosamines are considered carcinogenic. So because of this, the use of nitrite in meat has been discouraged. Some people don't use it anymore, and to ensure that color is not compromised, there are other color additives that can be added to still have the pinkish color of meat. Some of the other ingredients, we have what we call cure accelerators. These include ascorbate and ethobate. These hasten the development of the cured meat color. They also stabilize the color. They reduce the formation of nitrosamines, and they act as antioxidants, which means controlling rancidity. So sodium ascorbate, sodium erythobate, these are pure accelerators, and they have those functions. In some cases, we use phosphates, and phosphates affect water holding properties and meat binding, but they also contribute to avoiding rancidity, and they do that by holding metal ions that are associated with increased rancidity. If you are to understand the role of phosphate in water holding promotion, these different meats that are thawed, one had phosphate and one didn't have phosphate. This had phosphate, this one didn't have phosphate. When they are thawed, the one with the phosphate has very, very limited drip loss. Those without phosphate, the drip loss was much higher. So the phosphates help the meat to retain the water much better. Potassium sorbate, this is an anti-mold agent, but it also helps us against Clostridium botulinum. So it is really it has activity by activity against microbes, including molds and Clostridium botulinum. Then lastly, water. Water is also considered an ingredient for curing because it is a carrier for many of the other ingredients, but it also contributes to juiciness of the meat. Good, so I think that is really all with the cure ingredients, and we'll mention a little bit more later about the different methods of curing, but I've sort of tried to explain those methods. Any questions, any comments? So, what are the different?
Yes, Prof.
In
I wanted to know the difference between hemoglobin and myoglobin.
Good question. Hemoglobin is different from the chemical point of view. It has a different structure with able to hold more oxygen than myoglobin. So from the chemical point of view, they are different. But the other thing is within the muscle, we mainly find myoglobin. Myo means muscle. So they are different chemically, but also their location. The hemoglobin, you find it in the main structure of the circulatory system. Deep in the muscles, you are finding myoglobin, but they have differences chemically and in their ability to hold onto oxygen. Their affinity for oxygen differs. The affinity for oxygen under different oxygen tensions also differs, but they are close relatives. They all have similar protein, but different level of complexity and structure. Yeah. I was asking about different levels of radiation.
The different levels of radiation about pasteurization, which you said is much more related to pasteurization, and then the distillation.
Yeah. Okay. Then how does irradiation cause preservation? How does irradiation cause preservation, Amit?
You see, the radiation sort of inactivates the innate enzymes and microbes within the meat structure.
Good. Good.
It inactivates the enzymes, yeah.
Good.
Endogenous enzymes.
And how does curing cause meat preservation?
Curing, it reduces.
Any other thing? Any other way?
It preserves meat through increasing its gel strength, just as you gave an example in sausage butter when you apply there sodium chloride.
That is not exactly about preservation, but we said something else about why curing, apart from lowering water activity, what else may some of the curing ingredients do that cause preservation?
It preserves the color of meat.
Some of the curing ingredients are bactericidal. We say some of them kill microbes. Some of them do actually, like nitrite. We've said nitrite is a curing ingredient and it's an antimicrobial. We've said sorbate is a curing ingredient and it's an antimicrobial. Okay. So those are some of the direct methods. Then we said that what is the role of water in curing?
Water acts as a solvent carrier.
Okay. What's the role of sugar? What's the role of sugar?
Sugar is to counteract the harsh taste of salt.
Good. And it also reduces water activity like salt. It can contribute to flavor. What about ascorbate?
The ascorbate stabilize the color to meat.
Good. Anything else?
I've not got the science behind when Emma says that it is a solvent carrier. The role of water in curing,
It is a solvent. It's a solvent or a carrier of the other ingredient.
Okay.
So do you have any info about ascorbate and a response about the role of ascorbate? We've been told about its role in color stability. Anything else?
It is also bactericidal.
Ascorbate is not bactericidal, it is an antioxidant. Good. Okay. So those are some, a few areas of recap. Let's continue. We are going to briefly talk about smoking. Smoking is a traditional preservation technique, and it causes preservation because of some of the drying that happens, but also there are some chemical compounds that are formed during smoking. And smoking gives us some unique products. Apart from causing preservation, it adds to the diversity of products that can be created from meat. So it's a very important technique for preservation and for value addition. These are some of the constituents of smoke. We have phenols, we have alcohols, organic acids, and carbonyls, and all these have different roles, many of which are preservative. Like phenols are antioxidants, and every time we have antioxidants, they help with reducing rancidity. So phenols are an important ingredient of smoke. Apart from being antioxidants, they also reduce growth of microbes. So they are bacteriostats. They contribute to color and flavor of the smoked products. Alcohol, they also have a minor bacteriostatic role. In other words, they slightly reduce growth of microbes. Then they also contribute to flavor. Organic acids, they also have a minor preservative role. They contribute to skin formation, formation of a skin around the meat products being smoked, and they contribute to the red color in smoked sausages. Then we have carbonyls. This contributes to flavor and color of smoked meat. So smoke is a very complex mixture with all these chemicals. And when you see, these are groups, but in each of these groups, there are a number of compounds that fall within those groups. Apart from those positive, we have some negative, some components of smoke that have been associated with some negative consequences, health consequences. And the group is generally referred to as polyaromatic hydrocarbons. Polyaromatic just means they have several aromatic groups. The hydrocarbons which have some several aromatic side chains. And these are some examples of the polyaromatic hydrocarbons. These are associated with smoking. Using when the oxygen supply is limited, then there's a PAH increase. Also within the temperature range of 500 to 900, these conditions are considered favorable for production of polyaromatic hydrocarbons. And polyaromatic hydrocarbons, we need to re-emphasize, they are not desirable because they are associated with carcinogenicity. That consumption of meats that are high and that are contaminated with polyaromatic hydrocarbons is associated with development of cancers. And when it comes to the deposition of smoke on meat, there are factors which affect the level of deposition of smoke on meat, and these include the smoke density. Because when you have more dense smoke, then you have higher deposition. The air velocity of the smoke, how quickly is the smoke moving? This one is not a straight line kind of relationship in that when you have too high or too low speed of smoke, then the deposition will be slowest. You need the right, which is the optimum is in between. It's not necessarily recommended that the smoke should be moving very slowly or very fast. There is an optimal which requires it not to be too slow, but again, not too fast. Relative humidity, with the high humidity, you have smoke deposition being high, but the color development being slow. So again, with humidity, there is a range which would be most appropriate. And then the casing, a lot of meat products, as we'll see a little later on, are packaged in casings. They are stuffed in casings. And some of the casings do not have good smoke penetration properties. That would mean that when you're going to smoke meat, your selection of the casing is an important consideration. Then we have different types of smoke houses. We have those which are naturally circulating. That means that the smoke is by itself. Then we have air-conditioned or forced ventilation. This is where you have artificial circulation of the air. But the other option is to have your air still, but then the meat is moving. So you may have natural air circulation, but the meat is moving, and that would constitute number 3. So that is it with smoking. Any questions and a comment with smoking?
Yes, Professor, I have a question. When you show the picture of indirect smoking, can you please explain how meat is smoked indirectly according to that?
Good. Anybody wants to attempt explaining indirect smoking? Joseph. So let's imagine you have a chamber where smoke is being generated, and you release that smoke at the pace you want. You can have dampers which remove a bit of the moisture, but also, which introduce a bit of that, but the speed of the movement of smoke from the smoking chamber to where the meat is can be controlled. So over there you have a regulation of of smoke movement. It's different from when you have the meat just above the source of smoke, where there is direct smoking or direct introduction of smoke onto the meat. So imagine, even if you thought about it as 2 rooms, one room or one chamber has the smoke generation, and there is some sort of barrier in between this, or some sort of control between these 2. That is what happens in indirect smoke.
In this case, we can say the meat is dried because the smoke is go apart.
That is a good question. You saw I even indicated that we have cold smoking and hot smoking. Smoking and drying are not things that must always happen together. We have some smoked meat products that are not dry. So you can smoke even under ambient conditions where it is a bit is being smoked, but it is not being dried at the same time. Meanwhile, when you're dealing with direct smoking, then there is loss of moisture because the temperature at which the smoke is being generated is a bit high, and the meat also gets exposed to those temperatures. So absolutely, you can have meat which you're smoking, but you're not drying. Is that understandable?
Yes, I'm going to read to understand more.
Okay. Now, any other comments? What are the, I'm going to now be the one asking, what group of chemicals or components of meat are considered, of smoked meat are considered carcinogenic?
Polyaromatic hydrocarbons.
Polyaromatic hydrocarbons, good. How can we reduce the generation of polyaromatic hydrocarbons?
There is, it's advised that you smoke in large presence of oxygen, and also there's a range of temperature in which you're supposed to smoke so that they are not formed.
Good. What are some of the factors that cause that are associated with the slow deposition of smoke on meat? What factors affect the rate of deposition of smoke on meat?
Capacity of smoke.
I didn't hear that.
The density of smoke, the amount of smoke.
Yeah, but the density, yeah. Anything else?
The type of wood that is being used for smoking.
How does that affect the deposition?
There are some types of wood that are high in these particular compounds, the polyaromatic hydrocarbons.
Yeah, you've introduced something. The question was the factors that affect deposition of smoke on meat.
You mentioned about 3 factors. We talked about relative humidity and we talked about smoke or air velocity.
So can you explain air velocity a little? How air velocity may affect the deposition? Anybody able to explain air velocity, its impact on deposition of smoke?
It is inversely proportional in that during smoking, when the air current is moving at a lower speed, then there is a higher deposition rate of the smoke on the meat product. And when the air current or the flow of air is at a quite greater speed, then the deposition of the smoke particles in the meat will be very few.
Anybody has a different opinion or modification of that? We said too slow doesn't cause adequate deposition. Too fast doesn't cause adequate deposition. So there is in between that is more suitable. Okay, so we're going now to talk very briefly about fermentation, which is another method used in meat, fish, hardly in poultry, but meat, fish. And some of the fermented products include sausages, and this contributes to variety of products, the diversification of products, and at an industrial level, normally we prefer use of culture. In other words, microbes that have been known and selected and specifically added. They are added to the meat. Normally, the meat is minced and some substrate is added, usually sugar, to the meat to cause the fermentation to happen, and salt may be added, which introduces the benefit of inhibiting pathogens. Normally, these microbes are lactic acid bacteria, and these help us to cause meat to be stable, but also to be different. These are new products that you make through fermentation. You have pH that would be a bit acidic, which gives you unique taste, unique flavor in meats, but also at the same time causing preservation. So that is all we'll say about fermentation. And somebody had posted a question about drying, or a comment about drying. Drying is yet another technique, and it leads to reduction in the amount of water in the meat. And because of that, the microbial and the biochemical processes are slower. This can be done alongside other techniques such as application of sugar and salt. In other words, drying can be done alongside curing. It can be done alongside smoking. And these all help in preservation. Apart when we are using cure ingredients alongside with the smoking, with the drying, normally some of these cure ingredients have antimicrobial activity. Things like spices that are added during drying can help achieve better preservation than drying alone. So that is, I think, it with these methods that I wanted us to get exposed to, which are wide range, but help with the preservation of non-communicated. But you've seen that some towards the end we are mentioning things like sausages, which are communicated, but we have non-communicated products that are not preserved using this technique. Any questions? Anybody knows dried meat products? What dried meat products are you aware of?
Machomo.
Say that again.
The one that you make at home on skewers, meat skewers. That's a meat product from. It is normally dried or barbecued.
There is one thing about preservation, and it depends on what you do. But sometimes preservation and preparation are different things. Sometimes we are preparing food so that we eat it. But then you can make food so that it is preserved for future consumption. So when you're normally just roasting, oftentimes your business is more about preparation. But then you can have food dried so that they are for future use, which is then preservation. So what you do at home, you have to decide: is it preservation? Is it preparation?
Smoked preparation.
Smoked preparation.
Yeah. What about the smoked fish that they sell? That
that's a good example of preservation and preserved dry product. Good. So these basic techniques that we use sometimes for preservation of meat. I mentioned before that you should read about meat color and meat microbiology, but I'm also going to send you a brief article which is about these traditional methods, but also mentioned some novel methods. Many of these, apart from irradiation, are really traditional, but we have a few novel techniques of preservation that I also want you to be able to read about, and I'm going to send that also in the email I'm going to share with you so that you read about it. With that, I think we'll conclude at that point. And if there's, yes, please go ahead. Go ahead.
I wanted to know whether these preservation methods are also applicable to fish and poultry.
Yes, largely. I mentioned, for example, that for fermentation, mainly beef and meats and fish have not had much of that with respect to poultry, but generally, yes. Generally, yes. Okay,
thank you.
so I'm going to send these right away. And as I mentioned, keep abreast. We are about to, actually, you should start preparing for tests. I think very, very soon we ought to have a test so that whatever we've done, we have it evaluated before we continue. Okay. Good. So with that, we'll end today's class and